I'm Danielle Gaggi from Commercial UAV News, and today I'm following up with Alex Harmsen, CEO and co-founder of Iris Automation, about some of the topics that came up during our May 13th webinar. Is the world ready for drone delivery? Welcome back, Alex.
Good to see you again.
Good to see you as well. So one of the questions we didn't really get to, but we had intended to get to, is when it comes to drone delivery implementation, regulation and logistics questions often come first, and then we talk about the technology. Can asking those technologies questions first help ease challenges with both of these issues?
Yeah, I think that if you look at the problem of drone package delivery, if you look at the problem of industrial drone use, flying beyond line of sight, the the biggest things I think aren't actually the technology issues themselves. At the end of the day, people have done a lot of work over the last 10 to 15 years on commercial drones, on building everything from motors and GPS systems to airframes and certain sensor technologies to actually make these drones useful as payloads. I think the thing that people run up against is the regulatory approvals, and I feel like a lot of people blame the government when in reality, there's certain safety systems that can be used. There's a lot of different techniques that the FAA and other aviation agencies have authorized, or that they allow for risk mitigation. And so, at Iris Automation specifically, we focused on trying to create a technology, build sensors, work on approvals to be able to get past those regulatory issues. And so I think that the question isn't really technology or regulation. It's regulatory approvals through the use of technologies, through these kinds of products. And I think that's where a lot of the conversation should be. It feels like we're focused a lot on, we have a drone and now the barrier is the regulation. The question is, how can we augment the drones? What can we do to the operation to be able to make it past those regulatory approvals? And that's where I think a lot of people have been stuck. That's why we're trying to help people get unstuck in that area.
You raise an excellent point. They both have to kind of work together. So during the webinar, you actually kind of talked a little bit about how your initial responses to the FAA and dealing with them. You talked about the disappointment you initially had 3 years ago when you first went to the FAA with your detect and avoid system. And you also talked about the amount of data you've collected and collated to make a safety case for that solution since then. Every test and IPP program you have participated in has added to that body of knowledge. And that for me was particularly poignant. When we talk about implementing drone delivery or any new technology or workflow, most companies or organizations are not going to jump without having the facts. Is it safe? Is it going to make work easier, safer, quicker, or cheaper? How has systematically gathering this information really impacted the success of your business, especially when working with regulatory bodies like the FAA?
Right. Yeah, like you said, 3 years ago, we had a finished product, right? We had built the technology, we had a certain amount of data, and we went to the FAA, and they said, this is a great start to our conversation, right? And it took sort of another 2.5, 3 years to get to this point where we have an approved, system. And so, that process on its own is extremely valuable for a number of different reasons. And I think actually the regulators and customers of ours are the same. They don't just want the tech, they want to know, how can we trust the tech? How can we trust this product, especially a safety system, especially something that plugs into their autopilot, that's going to control the drone for a part of the flight. And so for something like that, like you said, tremendous amount of data, flight testing in the real world, flight testing in simulation and hardware in the loop setups, lots of automated software testing. The data that we collect, we're able to use that over and over again to improve the system. Our system needs to not just work, in the desert in Reno, it needs to work all over the world. And so we work with a lot of different partners. Our flight operations team travels all over the country to be able to conduct trials and missions in different environments and different environmental conditions. And that body of knowledge, we found different ways to be able to build that trust with, the stakeholders around us. And so part of it we put up on our website. Part of it we share directly with customers. Part of it we put into the regulatory approvals and the applications. Uh, Part of it we're publishing. So there's a lot of different ways to be able to build that trust, and a lot of it stems from the initial data, the reliability testing. On top of that, at a certain point, people just need to see it with their own eyes. And so, we've invited the FAA and other aviation authorities to come out and see demos across, 8 different states at this point, in Canada, in South Africa. We're doing demos in Brazil in a couple of weeks for the government there. And so, there's a lot going on, both through data aggregation and sharing and just seeing it in the real world. Because, there's a sort of this serious trust but verified type situation going on here.
You bring up an excellent point. Bringing that data is more than just regulations. It's about that business case as well. People aren't going to throw money at something they don't understand. So the next 3 questions we have are audience questions that happened during the webinar that I thought were particularly interesting to dive into. Some say that the best way to make a small fortune in aviation is to start with a large one. What path do you? And that's really hard when you're starting off with nothing and you want to build your business. What path do you see to make this accepted enough by the general public, especially in more developed regions, to make drone delivery profitable for some of these businesses?
I think that we're in a unique situation in the drone world right now in terms of general aviation, commercial aviation. We saw a lot of the fortunes in aviation being made by Boeing and Raytheon and Lockheed Martin, and a lot of these companies that are mammoths today. They started in the 1910s and 1920s, 1930s. Maybe not by the names we recognize them by today, because there's been subsequent acquisitions and mergers over the years. But it was then where things were not very regulated, where there was a serious interest. There was a few players that could really own the space. People that build both vertically integrated and horizontal technology stacks. And we're in a unique, similar unique situation now with the drone space, where they're relative to general aviation, there's not very much regulation. There's a lot of new technologies. There's a lot of opportunity for drone companies in this space. And there will be a few winners that come out of this that I think can actually, have they have a chance to be the Boeings and Lockheed Martins, of the space over the coming years. I do think it's frustrating how slow it moves relative to some of the other industries out there. But, at the end of the day, we are talking about safety. We are talking about relatively complex systems. And so I like this saying, it's maybe it's a little sad that it exists, and how true it is in the world of general aviation. But I think in the drone space, I think there is still tremendous opportunity, and we are just scratching the surface on what's possible with drones, especially in industrial applications. Package delivery hasn't even really started yet. I just don't think we're anywhere close to hitting our stride with that.
So, you bring up a good point. We're thinking of package delivery as bringing, those items straight to somebody's home, but business to business type applications haven't been explored in a big way quite yet, and there's a lot of possibility that's still out there. Do you think that finding those niche solutions that can answer those business to businesses might be a great way for these startup drone companies who are doing delivery to kind of get their feet wet and grow?
I just saw this morning that Amazon bought another 13 jumbo jets to add to their fleet, and it's sort of, I mean, I don't have any, 767s like showing up at my house to deliver packages. It sort of makes you think that, and, realize that there's an entire delivery network behind, what shows up on your doorstep. And so even if it's a driver or a sidewalk delivery robot that shows up at your doorstep, most of the logistics supply chain actually happens behind the scenes, maybe not even business to business. It's just internally in these larger organizations. I've spent time in like in the Arctic in northern Canada, and there's a 6-week window most of the time when you can get ships in there. And so, because the ice melts and you can actually get ships to come into this passage, everything else is flown in by plane. And it makes complete sense to do that with drones, especially larger cargo drones. There's nothing to hit up there. The chance that you're encountering other aircraft is low. If something happens to the drones and it falls, you lose the cargo. There's a lot more human lives that are lost than without drones than there would be with drones. And so, whether it's Alaska or northern Canada, or in the U.S., there's a lot of relatively remote areas where it would be very safe to fly. You would need some sort of system to be able to integrate into national airspace. But starting off with downtown San Francisco is probably not the right way to go. And so I think there's hundreds of thousands of applications in rural areas, even involving cargo deliveries, plus all of the other sensor technologies and the industrial technologies and applications like agriculture and forest management and pipeline inspection, forest, anything like that.
Awesome. You bring up a good point about, it ties back to that building that data case. You start off in a place where maybe there is rural community that could benefit from that. You have a solution that could benefit the small area, but you're also collecting data. Data that can help build that safety case with the regulatory agencies and with businesses to start growing it. And that's how you start to grow things like that. So going on to the next question, what are some of the key challenges for Iris Automation in See and Avoid that you had to solve?
That we haven't solved.
You've had to solve, or you haven't solved yet, I guess is
right. Yeah, I think that honestly, this trust piece that we've been talking about is a big part of the problem, and much bigger than I expected, right? Because I see the technology, I see our data collection, I'm able to walk into one of our engineering meetings and understand, how safe it is. I'm able to understand the inner workings, but, to a lot of people, it's like magic. The computer vision, the artificial intelligence, how does it work? Is it radar? Is it not radar? What exactly does that mean? And so I think we underestimated the amount of time it would take to be able to just build up that trust with the community, with the regulation community, with other companies in the space. And that's why we've been doing these public demonstrations. That's why we're putting data out there, building out that trust. And I don't think it's the technology that's the issue. Surprisingly, you would think that like a complicated system like this, we have an incredible team of R&D scientists and PhDs in computer vision and people flying it in the field. That feels like sort of the tangible problem that's right in front of us, relatively easy to solve. The harder problem is how do we get people to trust that this will work repeatably, and it's more than the data. I think that showing it in lots of different environments helps as well. I think just breaking it down and trying to explain how the tech works in more simpler terms, doing things like explainer videos and walking people through it, letting people get their hands on it, is usually good. I think the other part is that just having detect and avoid isn't good enough. And so, like, I'm not saying that, just having detect and avoid will solve all your problems. And I wish I could say that, but, in reality, that's not the case. And so a lot of it is putting the safety case together. A lot of it is, going through this SORA operational risk assessment. It's about, understanding how detect and avoid fits into the rest of it. It's doing a command and control analysis. It's all the different parts of that safety case and this waiver application that people need to be able to put together. And I think the FAA is very open where they say, show us your use case, we'll evaluate it. We're not going to constrain you in doing that. But most people in the industry want a certain amount of guidance, and they want to say, just tell me what 5 things I need to do and I'll do it. And so there's sort of a global frustration there. And so, at Iris Automation, one of the things that we've done is launched this waiver resource center as well. And so next to our detect and avoid system, we also have this WRC waiver resource center where we allow people to essentially take their operation, put it into our system. We're able to give them a waiver application, build a safety case, essentially guide them through that process so it spits out an application on the other end to sort of demystify and help push people in the right direction.
Oh, that is great.
And so, hopefully that's sort of the other big hole that we saw in the drone space to help people move through that, the regulatory issues that we see.
Making the move from magic to reality in
Yeah,
a very
exactly.
real way. So my final question was, has any work been done to demonstrate that automated detect and avoid is actually more effective than a human visual observer?
Yeah, I'm actually really happy you asked that. When we did our testing in Kansas last year with the Kansas Department of Transportation, Kansas State University, and Evergy Energy, a utility company there, we were just doing testing all through last year in 2019. And we were doing testing with just the detective function on, sending an alert back to the ground station. We're doing automated avoidance maneuvers with our system. We were looking at, really what the most effective way to be able to do that is. And in almost all cases, the automated avoidance maneuver was faster, more reliable. It responded in a quicker way. Humans get distracted. I mean, people were on their phones. They didn't see things come up on the ground station. When you're flying beyond line of sight, especially, you don't see the drone. And so you don't know what direction it's facing, or you need to sort of reorient yourself in a different reference frame. So we did a lot of testing with Kansas there, and the ultimate BVLOS waiver that we got there, we actually were required to use the automated avoidance maneuver because of a lot of the testing that we did, I think. The other big set of testing that we've done, besides sort of the anecdotal stuff from our flight operations team, who, is completely convinced that automated is the way to go, we did a lot of testing up in Alaska. And so I think in 2018 and 2019, we did multiple, week-long test campaigns in Alaska outside of Fairbanks, where we actually put visual observers on the ground who didn't know they were part of an experiment. Essentially, they were blinded visual observers, well, blinded in the sense that they didn't know. And they were told to scan the area, look for man intruders, and call out if they saw something. And then we had our system on board, switched into an automated mode with the drone, and it was just flying around doing lawnmower patterns. And essentially, we did a comparison in real time of our system on board compared to the visual observers on the ground. And in 95% of cases, our system took an avoidance action before the visual observer was able to spot the aircraft, identify the threat, pick up the radio the pilot, and then the pilot respond to, get the aircraft out of the way. And that wasn't even using our 360 system. That was just looking in one direction. And so, we're pretty convinced that, that having the automated void of action is better in so many ways and is really the long-term future of drones. Plus, on top of all of that, it eliminates the need for a real-time communication system. You want your communication system, of course. You want to know where the drone is. You want to have the telemetry. You want the payload access, but you don't want your detect and avoid function. You don't want your air risk mitigation tied to your communication system as well, right? That feels like you're just sort of compounding problems, stacking one problem on top of another one. And so, this is one of the other reasons why we think onboard detect and avoid is the future, why it's, so much more reliable, and, why we're starting to get a lot more of these permissions, not just in the US, but worldwide.
Fantastic. Thank you so much for joining me today, Alex. I appreciate the extra time you've taken to delve deeper into the drone delivery topic.
Of course, I love talking about this, and I really can't wait for what the next couple of years has in store.
Me either.